So good morning and welcome to my session on Drop the Bass using Azure AI Search. And also what I'm going to be demoing in this session is lots of stuff with embedding and vector search. So basically it's a maths lesson. We're going to be talking about vectors, cosine, similarity. The music stuff is just to get you in the room and sit down and listen to it. A bit about myself. My name is Alan Smith. I'm based in Stockholm, Sweden. I'm originally from the north of England. I've been writing code for money since 1995, working as a C++ developer. And throughout that time, I've basically attempted to keep learning new stuff and always kind of be on the cutting edge of technology. So I was doing Java when everybody at my company was doing C++, and then I was doing .NET when everybody was doing Java. I started looking at an integration server called BizTalk Server when that was in early beta. Then I got into working with Azure in, I think, 2008 when it was released, when nobody else was interested in it. And then I started looking at AI probably about 7 or 8 years ago. I work at a .NET company. No one was interested in Python. Nobody was interested in machine learning until a few years ago we got this thing called GPT chat. And now everybody wants to learn about AI and machine learning. So I've been looking at that. I always like building stuff. I like experimenting, building demos, and just finding out fun stuff that you can do with technology. I'm focused mostly on delivering training courses. I don't get involved in projects too much. I'm too busy going around doing training courses, conferences and stuff to do a full-time project. I build proof of concepts when they're interesting. I've had the MVP award since 2005, so about 20 years I've been standing on stages talking about things, and also, as well as conferences, I work with local user groups, coder dojos, teaching kids how to code. I've also been involved with organizing conferences and the global boot camps. I've been involved with the Azure boot camp and the AI boot camp. And yeah, I mentioned I'm in the MVP program. I'm currently in AI MVP and looking forward to meeting everybody at the MVP Summit in Redmond, which is going to be fun. If you want to contact me, ask any questions, best place is on LinkedIn. My boss wants to send people emails if they email my company and I start asking questions. Sorry, he wants to send them invoices if I start asking questions through my company email. But I'll answer questions for free on LinkedIn. I did have some other titles for that, but I'm probably the only person old enough to remember the aeroplane movie with this Roger, what's our Vector, Victor. I was thinking of calling it Embed with Madonna, but maybe there's some copyright issues with that. So the reason I got started into working with embedding and all of this vector similarity stuff, I was working on a project, and I was building an image classification algorithm for an auction company where we got all of these photos of auction lots, and there's about 26 different categories. Based on the photo, we had to classify the image into one of these categories. It was an interesting project. We built it in Azure Machine Learning. We started on Monday morning. We had it in the test environment running on Friday at 5 o'clock. Quick project to build. We used about 200,000 training images. It was a fun project. We did have a couple of issues. It would classify toy cars as vehicles. So we also looked at doing text classification as well to be able to help improve that. Around about the time, I watch YouTube a lot. I learn a lot of stuff from YouTube. Eric Bernhardsen, he's Swedish. He used to work for Spotify, and he built a vector-based search engine, which is available on GitHub, and it's called Annoy. We'll talk about it a bit later. It's the coolest acronym ever. And in his presentation, he was talking about the reason that they built it was for finding similar-sounding music for Spotify. Because if you think about a recommendations engine, if I listen to stuff and you listen to the same bands I do, then if I start listening to a song, then we'll recommend it to you. But if you get a new artist coming in and they dump 20 tracks into Spotify, nobody's listened to it, so they don't know who likes it, so they can't recommend it, so nobody listens to it. So what they wanted to do was to say, well, based on what the music sounds like, if it sounds similar to stuff that you listen to, if it sounds similar to The Prodigy or Daft Punk, then we'll recommend it to people who listen to The Prodigy and Daft Punk. So it's based on similar sounding music. Now, that didn't really pick up my attention. What really caught my attention was that you could also use the same Spotify Annoy for searching for similar images. It's a vector database. And this demo really caught my attention because here's the actual search pictures, and these are the results that are coming back from these search pictures. And I thought that is awesome because when somebody is looking at an E-type Jaguar, what you can do is you can take the image, and instead of you doing recommended products on a website, you can find stuff that looks like the stuff in the image. So We tested this with Spotify and AI. At the time, the Azure AI Search did not have any vector embedding capabilities, and it worked fantastically. With the classification model that we trained for identifying the auction lots, it was good at identifying features in the auction lots, and we modified the model slightly, and it was fantastic at being able to do this embedding. So we built a proof of concept. It was a bit shaky running a NOI in a container in Azure, so we never really put it into production. Nowadays, we'd look at using Azure AI Search or some other vector-based technology. So Spotify and AI, coolest acronym. It stands for Approximate Nearest Neighbor, oh yeah. And Approximate Nearest Neighbor is the algorithm that they use, because this is the maths bit. They're doing nearest neighbor search in high-dimensional space. When you do embedding, you have 500 or 1,500 or 2,000 floating point numbers, and you've got to find a vector that's similar to those, which is hard, apparently. Well, it's not hard. It's easy to do very, very slowly, but it's hard to do in a search engine when you want to get a really, really quick result. So you can download this. It is really easy to use in Python. It's written in C++. It's fast, and there's Python bindings on it. And in probably about 8 to 10 lines of code, you can build a vector database. The cool thing about NOI is that it's free. It's pretty quick. You can run it on your local machine. The vector data aren't too big. You don't need to give a bag of money to a cloud provider every month for hosting it. The disadvantage is you can't add and remove things from the index. You've got to rebuild the index every time. I still use it. It's a really cool way of just playing around with it with vectors on-premise. Recommend it if you've got some Python skills. Now, the introduction that we usually get to embedding is when people talk about large language models, and they talk about text embedding. So if I just bring up these Jupyter notebooks here, I'm going to mention text embedding quickly because it's really important if you're working with large language models. So I'm going to run this demo. This is using Azure OpenAI, and I'm defining some text. I'll just zoom in on this a bit. And the idea of text embedding is if we want to search for text, we can do a keyword search. That kind of works okay, but sometimes we want to do an embedding search where we're interested more on the sentiment of the actual sentence, what the sentence means. So I've got a bunch of sentences here. The food was delicious and the waiter was very friendly. The main course was excellent and the staff were very hospitable. And then I've got that in French, and then I've got it in Swedish, Italian as well. And then I've got 3 sentences about embeddings and 2 sentences about kids playing in the park. So what we can do is I can define that array, and then we can actually get embeddings from that by using an embeddings model that's hosted in Azure OpenAI. So we do that. And what we get is a big bag of floating point numbers, 1,536 dimensions in this vector. But what we can do is we can compare these vectors using something called cosine similarity. And this is one of the ways of doing it. There's other ways as well. So what we do with cosine similarity is we do this NumPy formula here. If you remember back to school, the cosine of an angle of 0 degrees is 1.0. 90 degrees is going to be 0, and then 180 degrees is going to be -1. So the cosine similarity is a measure of how close the direction of these vectors are. Not the only way of doing things, but it seems to work well in most scenarios. So what we can do is take 2 of these sentences, we can create the embeddings on these sentences, and we can look at the cosine similarity. So that's 0.919. It's not a percentage, it's a value of the cosine of the difference between those 2 angles. So those basically mean the same thing. But the really cool thing is, if we change the language, and we run this, we're now comparing English to French, still 0.919 as the cosine similarity. And we can go on to a different language here. When we're combining English and Italian, still 91% similarity. So vector search is cool. This is my opinion, and I get shouted at by data scientists sometimes for saying this. They don't like me saying it. Vector search is not better than keyword search. It's different. And I have a strong argument for that, because I kind of had this scenario, well, what if you've got products and you want to look at the configuration for widget 137, the configuration for gadget 583. There, the sentiment is very, very similar, but the keyword of the name of the product is different. So in some cases, a keyword search will work better. In some cases, a vector search will work better. So it's good to understand and use both. Kind of like if you're into databases, people who say a non-relational database is better than a relational database. Yeah, for some things, but not for other things. So we can create little diagrams. I'm in a Jupyter notebook here, and we've got matplotlib, so we can do that. And what I'm doing is basically doing a matrix, and these color values are showing the cosine similarity. Obviously, if it's comparing with the same sentence, it's 1.0, but you can see these groups of sentences with similar sentiment are grouped together in those areas there. So yeah, embedding and text embedding is really, really cool. So a bit about what's going on in text embedding, because the human brain can't really process 1,526 dimensions. But we understand 3 dimensions, and we understand, the red, green, blue color scheme. So the color Azure, 0, 1, 2, 7, 2, 5, 5. Data scientists would say, well, it's 0, 0.5, 1.0. And you can project lots and lots of colors into 3D space, and it kind of makes sense that similar colors are in similar areas in that 3D space. So a graphic designer would argue that dark Azure is similar to Azure. It's basically a vector with the same angle, but a different magnitude. And anything along that line is going to be a shade of Azure, and those are going to be similar. So in some cases, cosine similarity is the thing to use. Other times, you may use the Euclidean difference, which is when you do the Pythagoras, what is it, the square root of a squared plus b squared in 2 dimensions. You can do that in as many dimensions as you want. And here you can see that cyan is closer in the Euclidean distance to Azure. But you could argue that it's not as similar as dark Azure. And I've not really explored this too much. I've always used cosine, but there's various other ones. There's something called dot product, and there's another thing that I can't remember. So basically, these are different ways of comparing these vectors that you can do in these search engines. Now, vector search is really cool because it works with text embedding, and with Spotify Annoy, we also saw that it works with image embedding, and the original use of Spotify Annoy was to find similar songs. Anything that you can generate embeddings on, you can stick into a vector database, and you can search for similar stuff. They're really, really cool. So a quick demo of the image embedding. What we do is we take an image, and we get a bag of vectors for it. Now, this is really, really easy to do. You don't need to give money to Microsoft and OpenAI to use an image embedding algorithm to generate image embeddings. A convolutional neural network takes in an image. It has a bunch of these convolution layers, and at the end, it has this thing here, which is called a classification layer. Now, all of these layers identify things. We do edge detection, shape detection. Towards the end of the network, we do something called feature detection, so we identify all of the features. So these green nodes in the network are all basically floating point values which will describe the features. And then we use a linear layer, which is going to say, well, based on these features, this is a 0 or a 1 or a 2. Now, this is from Tess Ferendes. I think Tess is speaking in another room at the same time as me. And she did a fantastic presentation where she was explaining how all of this stuff works. So I learned a lot of stuff from watching Tess talk about this, where you can get different features, and the classification is used here. Now, typically, you'd use a classification network. The kind of standard things you do when you're learning PyTorch or TensorFlow is you download a data set with 12,000 cats and 12,000 dogs, the pets data set, and you train a model to be able to tell the difference between cats and dogs. So what you can do is you can just remove the classification layer, and you will get features coming out, these feature values, and that's basically the text embedding. So what we can do, if we want to create a similar text search, we get a bunch of images, we feed them through a slightly modified neural network, whack them into Azure AI Search as vectors, and then we want to search. We can take an image, do the same embedding, go to Azure AI Search and say, find me something that has cosine similarity with this image, and it's really good at finding these images. Okay, so next demo is looking at image embedding. So what I'm doing here is importing a bunch of stuff into the Jupyter Notebook. Now, I'm using PyTorch, and what I'm going to do is to, first of all, create an image classification model, which is this single line of code here. So I'm using the ResNet 18, which is a convolutional neural network that has 18 layers. It's the smallest one. There's also a 34, a 52, 100 and something, and 150 something. And these are different sizes. It specifies the number of convolution layers in that network. So that creates a classification model. This switches it into the evaluation state. We can see the model printed here. And at the end of the model, here is the linear layer that takes in 512 features, and it gives out 1,000 values. Now, these 1,000 values can be 1,000 classes, up to 1,000 classes, that you can use for image classification. We need to convert the images into floating point numbers and scale them to 224 by 224 pixels, or 224 by 224 by 3, because they're multicolored images. And then I can rattle through an image that contains photos of 10 dogs and see what ResNet 18 says about it. It's okay. I haven't trained it on dog breeds. These are the default weights that you can get from the model that's trained on different stuff. So it's saying English foxhound for beagle, boxer for boxer, boxer for bulldog. It got German Shepherd right. A bit confused with Labradors and Golden Retrievers, but you can see it's pretty good at being able to actually do classification. Now, I've written about 3 or 4 lines of Python. And using PyTorch. PyTorch is awesome. Now, let's get a bit more technical. What I'm going to do here is create an embeddings model. So instead of 1 line of code, I've got 3 lines of code. And this line of code here is removing the final classification layer and replacing it with an identity layer, which just feeds out those values. So what we've got at the bottom is this thing here, FC identity. Now, what I can do is do the same thing with dogs, but feed them into the embedding model. So what we get out now is a bunch of floating point numbers. So you don't have to give a bag of money to Microsoft to do image embedding. It's a few lines of Python if you want to do that. So what I can do now is to connect to Azure AI Search, because I've got an index called dogs vector index in Azure AI Search, and we can take a quick peek at that index, hopefully. So in AI Search, this is my dogs vector index, 12,300 entries in the search index, and if I search, we get back the file names. But the interesting thing is in the fields, I've got the embeddings, which has a dimension of 512. That's my embeddings vector. So back to the notebook. What I can do is, I'm connected to search. So what I can do is basically load up the dogs and iterate them here. So we can choose a dog. Let's go for dog ID 0. And what I'm going to do is to do a vector query on Azure AI Search. So where is the actual code that does that? It's a while ago since I wrote that. Oh yeah, that's the vector query. So I'm asking for 25 images that are the nearest neighbors to that particular dog, and the embedding is the field that contains that stuff. So if I run this, here's the original image, and here are from the 12,000 dogs, the ones that look most similar to this dog. So this is really easy at similar image searches. You may find scenarios where you want to do that, and it's not rocket science to build this stuff. If we test it with dog ID 4, the German Shepherd, you see it's finding other German Shepherds. So, and that worked really, really well for the auction house when we built that prototype. Some people like to buy kind of weird, like brass horse statues, and if you fed him one of those, it would just find other weird brass horse statues. And really nice way of being able to do, this one, the bidding went too high on this item. Maybe you'd like to buy one of these, and it's stuff that looks similar to that. It was really a really nice implementation. Okay, so we can also do it with faces. This was a fun demo. And the idea here was that, I work for a company. We very often have a booth at conferences. When we have a booth at conferences, we like to have something cool on the booth. So I thought, let's build a Terminator, which is going to do face recognition. So I said, okay, well, I did this at it's one of the conferences in Belgium. I think it was like Tekorama or Cloud Brew or something like that. And I said to a group of speakers, hey, is it okay if I use your face and details for a face recognition system? With lots of privacy issues. And speakers are cool. They all said, yeah, I'm on for that. Yeah, I don't worry about privacy or anything like that. Just, recognize my face and do the embedding stuff. So there's a network called FaceNet that allows you to, embed faces. And then you get a vector of what the face is like, all the features of the face. And then you can stick that into Spotify or Noi, and then you can search and do face identification. So this is the actual prototype for what I built. So if I run this, it should hopefully recognize me. I did all the coding to actually make it look like Terminator, or look as much like Terminator as possible. Come on. Yeah, so that's it. There's a Terminator vision, and yeah. Yeah, Alan Smith poses a unique threat to Skynet as he might just orchestrate the colossal Azure bootcamp, teaching all humanity to code an army of bug-fixing bots that could delete Skynet with a barrage of error reports and unmanageable server demands. So the idea was we're going to have this in our booth, we're going to have this Terminator thing, big screen, and when a speaker walks past, it identifies the speaker, and it comes up with a reason why they may destroy Skynet. So we're using GPT to... I think I've got a prompt somewhere that says, based on this text, generate a reason why this speaker could defeat Skynet. And yeah, this is the actual demo that I built. Where was it? Did I drop it here? Yeah. So yeah, Martin, who's sat down there, it recognizes him. And for each of these speakers, based on their speaker bio, it comes up with a reason. And Martin brews beer, so it says he can get Skynet drunk on his homebrewed beer. And I thought, this is going to be fun. And then the EU AI Act came along and said, you can't use face recognition in a public place. And we thought, well, they've taken all the fun out of that demo. I can still show it on stage. But again, this was fairly easy to build. The fun thing was, when I was building this demo, I was actually in Malmö, traveling back from a course. I think it was a course or a conference or something that I was presenting at. And I was on the train. I like to travel by train these days, so I'm taking the train back from Malmö to Stockholm. And this is when I basically sent out the message on the Slack channel to the speakers, and they said, yeah. So I started building the system in O'Leary's in Malmö. And then got on the train. I was in the regular, not in the first class compartment, the regular compartment, and it was completely packed. So I'm sat there coding this face recognition system, and normally you look at the person next to you and see what they're doing with PowerPoint or whatever, and people are just staring at me and going, who the hell does this guy work for? I should have worn the black suit and had the earpiece and sunglasses and the tie and everything and just gone the whole way with that. It would have been fun. So what I'm going to be focusing on now is working with music, and specifically EDM, electronic dance music, and thinking about how we can mix music together and make it sound nice, which is what a lot of DJs want to do. They use this thing. This is called Rekordbox. It's a free download. So if you're old, like me, you've got MP3 files, and you can just index your MP3 files, and it identifies all kinds of stuff like the BPM and the key, and gives you a waveform. It also identifies the phrases in the song, like the verses and choruses and the ups and downs and drops and all types of stuff. And it's what pretty much most professional DJs use. There's something called Serato as well that some people use. But Rekordbox, I think, is the most common. And then I got into looking at something called Sonic Pi. This was because of Dylan Beattie, who is speaking here. He did a session at NDC conferences, Oslo, I think, on the art of code. And I was watching it at home, and this thing, Sonic Pi, popped up, and I thought, this is really cool. You can write code and make music with Sonic Pi. So I got into programming with Sonic Pi. And then when I was watching EDMs, these guys popped up. These are DJs from Mars. And what they do is they're really good at being able to do what people call mashups, where you can take, say, an a cappella, which is the voices from one song, and you can put it on top of a completely different song, and make it sound nice. So this is basically, I'll do a quick demo of what they do. I think I've got a video of that set. So what they do in this video is they're mixing 100 songs, 100 like festival anthems in 13 minutes.
Use it, break it, fix it, trash it, change it, melt, upgrade it.
Put your hands up,
Chart it, point it,
put your hands up,
snap it, work it.
put your hands up for Detroit, a lovely city.
Technologic.
Put your hands up for Detroit, Riverside, motherfucker.
Yeah, sorry, I forgot to give the parental warning. This presentation may contain explicit lyrics at the beginning. Yeah, so that's what they do. They originally did that mix without showing them DJing, and everybody commented on YouTube and says, oh, you've just pre-recorded that. There's no way you can do that live. So what they're doing is, if we just drop into the slides and kind of showing what's going on here. So the big happy guy who's on kind of the this side as I look at it, he's basically playing all of the tracks, and then the little sad guy is doing the mixing here. So you can see he's got these little a cappellas and blocks of songs, and they just basically work together on these 4 decks, mixing this stuff together. However, that stuff is expensive. This is the price in Swedish crowns. I think it was going to be about 150,000 crowns if you wanted what they were playing with, which is kind of these 4 decks and a nice mixer and all the cables that connect everything together. And then you don't even have a sound system. You've got to plug it into speakers and amps. So it's crazy expensive to do this stuff. You can buy for, 300 euros, you can buy a little sort of cheap USB controller deck. And that works fine on a laptop if you just want to play around and experiment with the DJing. So what I thought is, can you do this in Sonic Pi? Because I can't afford that. Also, I haven't got the coordination because I'm old of being able to hit all the buttons at the right amount of time. But I can write code. So what I thought is, can I do what they were doing in Sonic Pi?
Buy it, use it, break it, fix it, trash it, change it, melt, upgrade it.
Put your hands up,
Start it, point it,
put your hands up,
snap it, work it.
put your hands up for Detroit, a lovely city.
Technologic, technologic.
Put your hands up for Detroit, Riverside, motherfucker.
So it sounded really good until then. And one of the things that you can do in Rekordbox but you can't do in Sonic Pi is key shifting, which they do to basically, if a song's in the wrong key, they'll just push it up into a different key. You can do it with code in Python and Librosa with a utility called Rubberband, which is what I've used, but it doesn't do it kind of in real time. And so a couple of things are wrong with that. It didn't sound that great. Also, I'm kind of stealing somebody else's mix, which is not good to do kind of in the DJ community. I'm just kind of taking all of their creativity and just repeating it. Also, this is basically static coded. So there's a thing in the DJ community about doing pre-recorded sets, which is apparently not a good thing to do. Some of the DJs, apparently, they don't actually mix things live. They just basically play the set, and then they wave their arms around and pretend to press the buttons. There was one DJ, I think, can't remember his name, but his laptop crashed, and everything just basically went dark, and the music was still going, and he didn't really know what to do on stage. So that there is a thing that people say, this is real DJing, I never do pre-recorded stuff, and pre-coding everything probably isn't going to be the best way to do things. You want to live code. And I'll talk about that later on. There's some great artists who are just basically standing up live and doing DJ sets from Sonic Pi or from Strudel and doing really, really creative stuff. So I wanted to be able to kind of find songs that sound good together and be able to do that. So I thought, well, this is easy. I've done similar sounding, similar text, similar images, similar faces. I know lots about embedding. It shouldn't be hard to find similar sounding beats. So I took out my MP3 collection. I used a network called VGGISH, got music embedding, stuck everything into AI Search, and basically created this similar music search. And then I went round, and this is the first iteration of my session when I had similar sounding beats. So if we drop into the notebook that I was using, I used this at NDC Oslo and a couple of other conferences. So yeah, this code here, if I run this, we're going to connect to Azure Search. And then the cool thing about Azure Search, this is something that you cannot do with Annoy. It's a hybrid search, so as well as being able to search based on the vectors, you can also say the artist is equal to this, or the BPM is greater than this and less than this, if you want to search for a particular BPM. So let's search for Prodigy songs, and it comes out with stuff for music from the Jilted Generation, one of the Prodigy CDs I've got. And we've got Voodoo People, which is track 7. So what I can do is take track 7, I can get the embeddings from the first, I think I'm using the first 30 seconds or the first 30 beats of the song. I think I was using beats because it was in in Recordbox, and we can find similar sounding songs. So this is, obviously the most similar sounding song is going to be Voodoo People, because that's going to have the same embedding as this. When I saw the results, the most similar sounding song to Voodoo People was Disco 2000 by Pulp, and I thought, no, but... And you got Therapy. You got the Dylans, Pixies, R.E.M., Radiohead, and it goes on. Sonic Youth, New Model Army. But you can tell what it's doing is it's just finding similar sounding stuff. And I thought, yeah, it's good, it works. And then I thought about, well, what happens when you mix these things together? It sounds absolutely awful. So when mixing stuff, you don't really want to find similar sounding stuff. There's a different mechanism that you've got to use if you want to do this with algorithms. So this was kind of my first iteration. I did actually play around and try to get it so you could go in from one song and mix it to another song. It was hopeless. I knew that if I picked a particular Depeche Mode song, and then it would show, and there'd be like song 4 that I could pick that would sound okay, and then I could go to song 6 in the next search and it would sound okay, but it just wasn't working correctly. And my boss, or technical manager at my company, he's really into music. He does DJing and puts lots of stuff out on SoundCloud. And I showed it to him, and he basically said, this could maybe work if it's a bar and you're playing background music and you're not playing it very loud and people aren't paying much attention to it. He's really polite. It wasn't very good. So I thought, I've got to get a better example working, for my presentations that I'm doing, but also for myself. I'd like to be able to use this. So I've shown a quick, the Azure AI Search index I'm using. I'll show that a bit later on when I've got the actual embedding. So I started learning a bit about music theory, and this is really mathematical. And there is something called the circle of fifths, which was in the 1600s, early 1700s. And it basically says that certain keys are related. There's, for a major key, there is a minor key that works with that key. So if you're into music, if you play the piano, for example, C major is C, D, E, F, G, A, B, C. And it's all the white notes up from C to the next C. And then A minor goes from A to A across on all the white notes. It's a minor chord. So each of those major and minor keys will use the same notes. Also, because of the circle of fifths, C major is fairly similar notes to G major and F major. Those might work well together. So when DJs look at doing this, there's something called the Camelot wheel. Instead of learning about D flat minor and A flat minor and F sharp major, they have these indexes like 1A. So if you're playing in 1A, then you can go to 1B or 12A or 2A. Easier to remember the chords. I like using the traditional names of the chords because I've done a bit of music before. So yeah, if you're playing something in like G major, then these are the other songs that you can mix with it. So there's that theory that you need to think about. And that allows you to do something called harmonic mixing. So Sweet Dreams by the Eurythmics and Enjoy the Silence by Depeche Mode are both in the key of C minor. So if you go to Sonic Pi, I'm going to try and do some live coding here, which may not go too well, but I'm going to try anyway. So you can basically have something called a live loop, and the idea is that you don't copy-paste stuff, so I'll try this. So if I go for the... it's not... Oh, I spelled sample wrong. So I've got to get this right. It's SAM tab space colon E. And I've put... In Sonic Pi, you can basically put all of the samples as FLAC files in a samples folder, and it gives you autocomplete on all the samples, which is really, really useful. So I want the intro for Sweet Dreams, which is that, basically. And then if I want to go to the... I'll start copy-pasting now. I'm going to make mistakes. We can bring in the vocals for Sweet Dreams. But instead of having the intro for Sweet Dreams playing when the vocals comes in, we can swap it for one of the synth tracks from Enjoy the Silence. Enjoy the Silence on YouTube, you can basically download isolated vocals, bass, synth, drums, all kinds of stuff. So you can basically chop these up and put them back together in different ways and create your own mixes. So what happens is this is running this live loop and doing a sleep 32. This is showing where we are. So if I run this, the next loop, it will change to this.
Sweet dreams are made
And then this is 64 beats, so I comment this out and then change to section 9 from the synth track and enjoy the silence. And you kind of hear at the end of 8, this choral effect comes in.
Some of them want to use you.
And that continues into track 9. But because of these are in the same key, this works. It kind of sounds okay. So that's basically what people are doing when they're doing harmonic mixing. But if you want to do this using code, if I drop back to the deck, then we need to think a bit more about, how can we find phrases that match with each other? So what I'm doing, I've basically got tons of MP3s. I've stuck them into Rekordbox. So Rekordbox looks like this. And I've got a track list. In master tracks, yeah, I've got like 12,000 tracks. But if you just go to the regular tracks here, I've got other stuff here. If I drop in 9 PM by ATB in here, what you see is the actual waveform, and then you see the beat grid saying, well, we've got the intro, and then you've got all of the different sections. Now, sometimes it will, I don't know if there's an example where it gives the ups. Yeah, this basically gives the ups. So this is a section of the track. I'm not connected to the right sound thing. Audio, I want to be on. I think it's that one. So that's that section there, and you can see it's like progressing up. So you get the identification of the BPM, the key and everything. And it does allow you to do stuff like the actual tempo shift. So you can increase or decrease the BPM, and it can also do like matching. So if we drop in Insomnia there, they're different BPMs, but there is a button called Beat Sync, which will basically put them in the same BPM. So you can basically, play these tracks together. You can also create loops. So if you want to loop a particular section of a track, you just basically. So it's just going to play those beats, and then you can mix something else into that. So this is, fun stuff to play around with. So what I'm really doing is taking this stuff and putting it into Sonic Pi. So what I needed to do was to get the information from the Rekordbox database, which is the artist track, phrases, and so on, and get the actual phrases, do the embedding, split the tracks into the phrases, generate separate MP3s, and also push them all, compress them all to 126 BPM, which is what I'm doing in Sonic Pi. Also create the waveforms here. Now, the developers of Rekordbox try to make this difficult. They've encrypted the database with a key. They've done really weird file formats with the actual waveforms. They haven't provided any documentation on that. And they also do evil things like putting XOR flags on top of the wave filters so people can't actually, so it's hard for people to figure them out. Which is a pain because smart developers who actually build the libraries that you use to access the record database have to spend their weekends figuring out how to actually get the data back into a readable format and how to decrypt everything, which we've done a great job of. And you can download, there's a Python library called PyRekordbox, and I think it's called PyRekordbox, and there's a Java version as well. So that's what I'm doing to get the information out of Rekordbox. And again, I'm sticking that into AI Search. So extracting the phrases, what I do is I basically go to each phrase, and I'm sticking that in as an index within Azure AI Search. It's JSON, it looks up something like that. We've got the song artist, we've got the title, we've got the key, the original BPM, the label. And then there's the extra labels. So you've got like up 1 and up 2. So up 2 is meant to be more up-tempo, and then up 3 is going to be even more up-tempo. And that kind of helps you when you're selecting stuff to figure out what's happening. Start and end time in the track, start beat, end beat, and start bar. A bit of information like that. And I do that for all of the actual phrases within the track. However, with embedding, we want to have the same dimensions in everything. So what I do is I take a particular section. I'm taking 32 beats. So this is.
This could be a good night for good times, and you look like a good time. We're dancing to this. This could be a good night for
And this is something called a MEL spectrogram, which is a melodic spectrogram of what the actual music looks like. Now, this contains a lot of information. And I was thinking about doing embedding using this, but within the, what's it called, the Librosa framework that I'm using, you can also get this. You can apply a chroma filter. And what this is giving us is the musical notes that are dominant within that particular section of music. And this is agnostic of what octave you're in. So if you've got bass that's using that kind of note sequence, you can find something that's using treble, that's using that note sequence, and maybe those would sound better together. So if I play this.
This could be a good night for good times, and you look like a good time. We're dancing to dancing in the moonlight. Now I want you back. Can you make me feel better?
You can play those on a keyboard, and you'll basically get that kind of chord information there. So this is what I'm using. There's actually no AI here. This is just maths. And I went to university and did an engineering degree, so we did fast Fourier transforms in maths. So this is basically the algorithms that they're using to get the MEL spectrogram. Not sure exactly what they're doing to get the chroma filter, but you can just call a few lines of Python and get that information. So what I'm doing there is, sometimes the embedded phrase in the database, it's always going to be like 8 bars, 32 beats. So sometimes it includes the beginning of the next section. So mixing the phrases, what I need to do is to push everything. I'm actually pushing everything to 126 BPM using rubber band. You can't do this in Sonic Pi. It would be really nice if you couldn't just change this. So I basically wrote code to push everything into like 126 BPM, so everything will sound, it will be beat synced when I basically drop it into Sonic Pi. And so what I have is this metadata file where you select a track. And it will basically list all of the phrases in the track, and you can preview those phrases, and you select the phrase. And then what it will do is it will take that phrase, take the embeddings of that phrase, go to AI search, come back with a list of stuff that works with it, and then it will basically generate the mixes programmatically for you, so you can actually preview the mixes. So what I'm going to do quickly is go into the vector-based harmonic mixing. I was thinking of just doing this as pre-recorded. I do have some pre-recorded stuff that I can show that I will do a bit later on, but I wanted to do it live because, live coding and pre-recorded sets and all of that stuff. So I did put something together in the hotel bar last night. I was playing around with Ferrari by James Hype, and it recommended another couple of tracks here. I was talking to Layla over breakfast, who recommended, who thought Underworld would be a good mix. But unfortunately, I couldn't get that to work. I didn't have a good song of the right tempo. It had like Born Slippy, but I think that's 136 BPM. And when you play at 126 BPM, it really didn't sound that great. So what I started with was 9 PM by ATB. And then it kind of recommended going for Dimitri Vegas Project T. So this is an up progression, 32 beats, so this is kind of a build-up. And then Ibiza. That gets us there. So what we want to do is we want to take Ibiza, who is it? Desperacidos. Ibiza, this mix here. And we want to find something that sounds okay with that. And I think I've got that ready here. So this is that track here. And the section that we had was bar 153. So if I drop down here, we can find bar 153, which is going to be this. And this is going to be phrase ID 15. I should really put a button and just click search here, but I'm not that great at front-end programming. But so what I have to do is go up here and put in the value of 15 in here. And here we've got the option to use embedding or not. I always use embedding to find the correct options. Also, I've got on the Camelot wheel, or the circle of fifths, what we're going to search for. I can have it in the same key, or I can just pick any key and not care about harmonic mixing. For a drum beat, you may want to go with any key, because it doesn't really matter. if that's just percussive rather than melodic. Or we can take the V keys. I didn't really know the technical term for these, but the V keys is kind of the one on the inner wheel or the outer wheel, or the horizontal keys, which are the ones which are to either side. Or you can take both of those as well. Now we'll stick with the same key, and I'll just go for 10 originally, because it does actually need to mix all of the actual files together, and that takes a bit of time. So what it's recommending, we've got Ibiza, it's recommending another track by the same artist, this Fiesta Loca. So that's the actual track, and when they're mixed together with this, it gives us this. And it was really nice to be able to actually finally, it took me quite a while to actually get out the waveforms from Rekordbox, because it kind of shows what the music looks like. I've drawn in these lines between the bars and beat lines, and all of this is matched up. And sometimes you can tell that if it's red, then there's going to be a lot of bass. And if it's going to be blue, then it's going to be fairly treble. So it kind of gives you a visual. You don't want to put two really bassy things together or two trebly things together. So again, I'm doing this live. I haven't tried this before. I don't know if there's anything that's really jumping out as being fantastic, and I want it to be 15 seconds. Oh, that was just a bass. I'll go for that. So what I do is I just basically select this section here. Bar 25, I want the bar in it. I'm just basically copy this, and then I'm going to download this. I haven't figured out how to get it to put the file names in the actual download there, but that will then download it into the mix folder, and I'll just check it's in the mix folder, NDC mix. Yeah, it is there. So what I then do is go into Sonic Pi, just paste in the file name, and then I can just go here and drop this in, take the MP3 extension, stick that on the end. Whoops. So you can, if you've got the predefined samples, what I was doing previously in the other demo was just doing stuff from that I've got in my sample library. Then it's got an actual name identifier, or if it hasn't, you can just select the files. And I haven't really dropped those in and connected them up to Rekordbox. So I just want to check that this sample works. Yeah, it seems to work. And does it sound okay with the other tracks? Yeah, it does appear to. So what we can do now is run this again. So this was, I'll skip that. I'll just stick that with the project. Sounds like that. So if you're doing that with the DJ hardware, you'd need 4 decks to have the 2 tracks running on one deck and 2 tracks running on the other deck. You need a lot of coordination to be able to mix things together. But Sonic Pi is free, and you can just bang as many samples as you want to get together. So other stuff that I found out when I was playing around with this, the mix I was playing when you came in, I've actually got it broken down into different sections. My eldest is really into music, and I always speak to them and say, hey, what do you think of this? And they're going, that works, that doesn't work. You're a quarter of a beat out on the vocals in that particular section, so it's good to get feedback on that. So I took like Smells Like Teen Spirit by Nirvana, and it recommended Lookout Weekend by Pulse Driver, which kind of has really the opposite sentiment. It's talking about going out and partying and stuff like that. So. We get to this bit here.
Load up on guns, bring your friends, fun to lose.
And it goes into the like hello, 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 and then it brings in like the vocals from Lookout Weekend and the build-up as well.
To the club at 12 o'clock, smiles high, a bass drum drop, riding 90 the night is young. Look out, weekend, time to get down. Push myself into the VIP. Homie, shake my hands, the ladies look at me on the dance floor. They hear the DJ play. Great goose like drinking champagne and spray. Bumps back to the maximum.
And I bring in the guitars from the It's just fun to do that stuff, to put you know, a couple of songs together that may sound good, may sound that. And then Layla was mentioning about, I think I did have, oh yeah, this was Prodigy and Depeche Mode, which I kind of liked. So here I'm just using a sample of the vocals from So that's something that I've cut together from Depeche Mode, and then it goes in a bit later to Do It Again by Chemical Brothers. So if I just comment those bits out, it was...
Oh my God, whatever they do, all I wanted was a little fun. Gonna bring that bubblegum.
And then what else was there? This is quite nice, but it's a bit long, and I guess I've got a bit of time. So the thing I liked about this was this like build up here from 20 Years on Acid is 128 beats. So that's going to be basically 4 of those 32 beat sections. So if I comment out this bit here, it's actually using Faded by Zoo. So if I comment out the kind of early section of that, it will just take the build up from Kate Lawler, 20 Years of Acid. So, so that's the lyrics that we're getting from Faded, which that's going to be 64. And then it brings in, I use 9 PM a lot from ATB. It kind of mixes well with other stuff. So that's 9 PM coming in. Then it switches to the second verse of Faded, which is kind of a synthesized voice. We bring in the drums from 20 Years on Acid. But this is still playing. This is like the big build-up. It runs all through this section. And that's running through these 2 sections. We then add more drums from and then it's getting towards the end of this section with that big build-up running across. So that was that bit there. I just think there's just one more that I can show. Basically, this thing runs for about, I think it's about 20 minutes of stuff that I've put together. I haven't really done with linking these sections, which I really need to go into, but I'll just play the beginning of a couple of others that are fun. So this is the a cappella, which is just the vocals from Rihanna, which I can just play that, and that's this.
Yellow diamonds in the light, I was standing so.
If you hunt around on YouTube, you can find a lot of these a cappella mixes. Sometimes you get a studio a cappella, which you really need. Sometimes there's an AI which will attempt to isolate the vocals from the music track, but they sound pretty horrible, and it's not something you could really play loud on a good sound system. It would just sound terrible. But if you can find studio a cappellas, they work really well. So I put in the Sky Full of Stars by Coldplay on that.
Yellow diamonds in the light, I was standing side by side as a shadow crossed.
I had this crazy idea of just converting it into Personal Jesus by Depeche Mode. It sounds a bit drastic.
In a hopeless place, we found love in a hopeless place. We found love in a hopeless place. We found love in a hopeless place.
Again, Personal Jesus is really cool because on YouTube you've got all of the isolated stuff, so you can just basically get the, sorry, I wanted the guitar, that bit there. So if you find something that works with this, you can just drop this in. I love that the Martin Gore guitar, it's never a complex guitar, but it always really forms the basis of the song like it does with Enjoy the Silence. And what was it, Ghosts again, the latest one that they did. But then the synths that they do on Personal Jesus are wicked. got this really like cool. You just drop into a dance track, and only Depeche Mode fans would know what it is. So that's fun. I'll just comment that out. Yeah, there was Kate Perry. I was mixing with Enjoy the Silence. I tend to use a lot of Depeche Mode with it, and various things like that. I think we've heard that one there. Yeah, so that's basically the mix I was putting together. I'm going to persevere more with this. I live in Stockholm, and last summer I did loads of windsurfing. I used to do windsurfing when I was a teenager in my early 20s, and I've got back into it now. It keeps me fit, loads of paddleboarding and stuff, and I thought, great, it's summer, I'm going to go windsurfing on paddleboarding. I spent 2 months building this demo. I think I went windsurfing once, paddleboarding twice, and just spent the whole time building this demo. What I'm not showing is the stuff that didn't work. I spent a month basically trying to train a neural network to classify whether music is in tune or not. So I took loads and loads of mixes, and there's 100,000 MP3 files of something that is in tune. And then I mixed together stuff in the wrong keys and generated 100,000 mixes of stuff that is not in tune. And then I spent weeks training a model on a big GPU at home, which is, if you're running this stuff at home, it's like having a hairdryer running in the living room for about a week. And that wasn't popular with the family because it's really hot. You don't need notification on it, because if you're in the kitchen and it suddenly goes quiet, the processor's crashed. I need to go up and fix something. It's stopped making noise. And yeah, so that just didn't work. And then I kind of looked more and more into the theory and got into actually doing the harmonic mixing. And that stuff did work. So I've got a few minutes left. I'm just going to talk a bit about the challenges of this project, because it wasn't easy. I had to copy 1 million files onto my laptop for this demo. It's ridiculous. So for the, I think it's 12,000 MP3s, and there's maybe about an average of 15 phrases per dance track. So that's going to be, I don't know how many phrases were there. I've got that in the actual search. It actually tells me that. So where's the indexes? Yeah, so 159,000 phrases. So for each of those phrases, I have to create the MP3 file that's in the right key. I also generate the embeddings for those as separate JSON files, because that's quite time-consuming. And then for the waveforms, when it's being displayed in the Jupyter Notebook, which is here, I'm creating, when we actually preview the phrases, what I wanted to do was to show the actual phrase itself, but then also where the phrase is in the track. So I had to generate like 2 ping files for each of those. So that took days, and it took a long time to copy this stuff across onto the actual laptop and get everything up and running and populate the data in search. So I was actually running a performance monitor on my F drive at home, because I kept running out of drive space and having to delete other stuff to make space for all of these embeddings and MP3s. Oh, that's what it looked like partway through the process. I think I've got 500,000 embeddings and MP3s, and then 500,000 ping files. I could create them in real time, but then the demo would run a bit slower. So I go the extra mile to make the demos run a bit quicker. Yeah, and then things that caused me problems. Again, Dylan Beattie. I used to teach BizTalk courses and talk a lot about integration. So we did with flat file processing. If we live in Denmark and Sweden and Norway, we have all these strange characters. And Dylan was talking about this, about how when Motley Crue were in Germany, they were calling them Mötley Crüe, because of the intonations. And Motley Crue just put those things there because they thought it looked cool. They didn't realize that in other countries it would affect the pronunciation of the band's name. And these always are a pain point in integrations. Does anybody know what these are? I bet nobody can name all of them. Now, typically, when you get an MP on YouTube, if you download something from YouTube, they use one of these characters to separate the band name and the track name. So you really want to split by this character. So sometimes they use a hyphen, sometimes it's a minus sign, sometimes it's a non-breaking hyphen, sometimes it's an N dash, and sometimes it's an M dash. They're all different characters. So that caused me a world of pain, actually splitting up the band names. I was saying, well, I'm splitting the string by this character, and that's that character, and it's not splitting. Why? And then it's a different character. It just, in Visual Studio, they all look exactly the same. Yeah, and then the artist and track names was driving me crazy. When I was young, they had nice names like Blur and Oasis and Pulp, and they had basically small, shorter song names. This is one of the artists and one of the tracks that I've got. So is it Martin Goodboys, Mattia Vetta and Simon Gadi versus Lucia de Grigo featuring Joshua Grammett, and it's The Edge of Infinity, Audio Hell, and Tayana Volcano and Joe Divina Kick-Ass Remix. And they all have stuff like that, which is a real pain if you want to have these as sample names in Sonic Pi. So one of the things I was doing, I have arithmetics instead of the arithmetics, because when I go in the autocorrect, I don't want to type the and see loads and loads of bands. So I just basically stripped out the from all of the tracks. I haven't tested it with the which might be interesting. More research I'm going to do. I found this data set. It's 666,000 chord progressions of songs, which is available on GitHub. Unfortunately, it doesn't give you the name of the song, but it gives you the Spotify ID, and you can maybe correlate and find out. That could be useful as well. There's an excellent white paper, Detecting Drops in EDM, a scientific approach to using social media and tracks on SoundCloud to figure out where drops are occurring in EDM music. That looks cool. So if you want to get in with music coding with music, I highly recommend checking out either Sonic Pi or Strudel. They're both free downloads. And then the master of doing this live coding is Sarah Davis, who goes under the name of DJ Dave. And on Sarah's YouTube channel, there's a ton of stuff looking at the actual music. I think I got one of her videos that is basically showing using Strudel.
Here is what it sounds like with a 4 on the floor. So I have this arpeggiator that's running through a sequence of notes.
So if you're into composing your own music, you know what
and I have the envelope set
and,
here,
all of this stuff. And the thing I
also
like
a
about
low-pass filter
this
envelope that's on a slider. So if I change the slider, it's going to make it sound
when
brighter.
you're playing the notes, you see all of these kind of notes highlighting.
And then I have a similar setup on this bass line up here, where I have the low-pass filter slider set pretty low, so it sounds more like a bass, but it's using the same sound and it's running through just a different sequence of notes. And then on both of them, you can see I have post gain set to a variable. So that variable basically makes it possible for me to sidechain these sounds to a kick drum. So if I bring those patterns in, it's also going to bring the kick drum in. And here is what it sounds like with a 4 on the floor.
So that's excellent stuff. Thank you very much for listening. My name's Alan Smith. I'm going to be around for questions. I'll be around for lunch. I've got to jump on a train back to Stockholm in the afternoon, but I'm happy to take questions after the session. Thanks very much for listening, and enjoy the rest of NDC.